right, students, this is Unit 6, Polygons, Lesson 6.4, Kites and Trapezoids. Kites and Trapezoids. Adios. We've got ourselves an audience here today. Look to what could happen for you if you stick around after school. We're doing lesson 6.4. All right, remember sure to get a date, time, and location. Here we are. Last class, we talked about rectangles, rhombi, and squares. Down below is a rhombus. Find everything possible, knowing that that is a rhombus. So we're going to hit the pause button here. You're going to finish and then restart. Pause. Alrighty, folks, let's see how you did there. We had ourselves a rhombus, which means you have a right angle here. Oh, looky there. That means a right angle. That's 60 right angle. And we have ourselves a 30, 60, 90, short leg. Short leg root 3, short leg times 2, which in the rhombus, all of these are going to be 14. And that's now the hypo. Our short leg is right here. You should have gotten 7 for this. And then this is going to be 7 root 3. Now, if you use SOHCAHTOA, you would have gotten this, 12.12, which is approximately the same thing if you use SOHCAHTOA, and you could have used SOHCAHTOA there. Okay, so that is a rhombus review. Today we're going to talk about another set of shapes, which are trapezoids and kites. So ask yourself this. I'd like you to draw yourself a little parallelogram. That's our parallelogram. And then come over here and ask, this is a trapezoid. This is a parallelogram. How are they different? How are they different? What are a couple differences? I'm going to hit the pause button here. I want you to write your own sentence. I'm not going to fill that out for you. How are they different? Okay, so hopefully you came up with a couple differences. So let's explore those differences. What makes a trapezoid is the fact that you only have one set of parallel lines versus a parallelogram, you have 2 sets. So that's what makes a trap, is one set of parallel sides. Now that trap has some unique qualities. The sides that are parallel are called the bases. Notice there's 2 of them. And then the sides that are not parallel are called legs. So there's 2 basic kinds of trapezoid. There's your generic basic trap, where you have one set of parallel lines. And then the legs are not the same. And then, if you make the legs the same, this is called now an isosceles trap. That isosceles trap has several characteristics. 1, it has 3 things congruent. By definition, an isosceles trap has legs which are equal. Two, the base angles, that means the angles connected to the bases. So those 2 blue angles are going to be congruent. And then the light blue angles are congruent. Notice the matching hatch marks. The angles are going to be, base angles are going to be congruent. Very similar to in an isosceles triangle. If you have two equal sides, you have two equal angles. So it's related. Isosceles trap, isosceles triangle. The last one that's congruent is the diagonal lengths are congruent. So right there, that length, dark green and light green. If you finger pinch those are the same lengths. Finger pinch. Put your fingers there. Put your fingers there and finger pinch it. You should feel that that distance is the same from here to here. Warning, that's not a midpoint. Be very careful about that. There's a couple other things here. Here we have an isosceles a trapezoid. E is a midpoint here on one leg, so hatch mark, put E. And F is a midpoint going the other direction. Hatch mark, F. Double hatch mark because it's your second set. When you connect the midpoints, this segment is called a median. Here's a property of medians. Let's see if you can recognize what that property is. So it says right here, I'd like you to connect E to F. That's called a median. It's also called a mid-segment in some textbooks. Okay, so we have here our base. Let me color code it. A to B. AB is a base. And notice RAB, let's check our units. Bunny hop that. RAB is 4 units in length. That's one base. Now let's check our other base, which is DC, count. That is 9 units. Yes, the top is 3 units, folks. 3 units, yes, and 9. Now let's add 3 and 9. That's 3. That's 9. I'd like you to average those bases, which means you're going to add and divide by 2. Check the average is 6. Now let's physically check the length of the median. Bunny hop it. Notice that's also 6 units. So what we just figured out is that this median is the average of the bases. The median is the average of the bases. So there's 2 ways I want you to simply write this. The median is simply the average of the bases. That's the descriptive version. And then the word version is median equals base plus base divided by 2, which is the concept of average. Very similar to finding a midpoint. Let's see you use this. Okay, remember equations have 2 sides with a equal sign. 2 sides with an equal sign. So it says right here the median is given with the information for the bases, find all lengths. So let's write this out. Median equals base plus base over 2. Medium equals base plus base over 2. Now we're going to circle plug chug onto our equation. There's my template. Our medium here is x. One base is 12. The other base. You do your own math. Double check your math with mine. I'm getting a median equals 19 units. Okay, again, let's do this one down here together. Let's start by writing our equation. The equation has two sides without equal sign. We'll start by writing median equals base plus base over 2. We average the bases. Now we're going to circle, plug, chug. Our median this time is 20. Our one base, it really doesn't matter which base is which because it's plus. Here's our other base. Pop this leftover 1. You're going to cross multiply and solve. Keep your head down on your own paper and check your math with mine as soon as you're done. You should have gotten x equals 9 then. Don't get all happy. This is not algebra class. You need to take that 9 and plug it back in and see what happens. So 5 times 9 is 45 minus 15 is 25. And then here we have 2 times 9, which is 18. Minus 8, that means it's 10. Now check your work. Okay. 45, 30. Yes, 30. Got it. We have 30 here, and then you simply add 30 plus 10, divide by 2, boom, and you've got your 20 right there. Ready? You try this one and the next page. Try that one on your own. Pause. Second. Okay here, so you should have gotten, if you did this correctly, again it's median equals base plus base over 2. Equations have two sides with an equal sign. So our median this time was 24 equals base plus the unknown base, 35 over 2. We're going to pop this over 1 on the left-hand side. Cross multiply. And we got x here is 13. Let's check. 13 plus 35, that's 48. Divided by 2, 24. There's your check. So trapezoids are pretty easy here. Now we're going to come to a kite. What I like you to do is I'm going to pause the video for a second, and I like you to mark everything you believe might be true about this kite. Mark anything that you believe might be true about this kite. Pause. All right, let's see if you found everything that's possible here. Kites give you a ton of information. First off, the main definition of a kite is simply consecutive sides are congruent. So notice the hatch marks there. It's the two sides next to each other that are congruent, not opposite sides. That makes a kite a kite. Now, what else is going on? Obviously, your crossbars have right angles. 2. This is the midpoint going this way, but it's not the midpoint going the other way. Also, these angles here are congruent. And then these angles here, notice those sweep marks don't match. Those corner, what I call the crossbar angles, they are not bisected, but they are congruent. Versus that red and orange angle, those aren't congruent, but they are bisected. So one sets are congruent but not bisected, the other one's bisected and not congruent. So you got a ton of information when you have a kite. Now knowing this, we need to do a few comparisons. A rhombus is on the left and a kite is on the right. I'd like you to write how, I'll tell you how they're the same. Drawing the diagonals, you have perpendicular diagonals. I want you to come up with at least 2 different ways that they are different. Okay, now that you've differentiated, now say, how are they similar? They were similar, of course, because they have right angles in the middle. Right angles in the middle. Okay, knowing this, for this one right here, I'd like you to find all possible segment lengths, side length, and angle measures. Segment lengths and side lengths you can round to the 10th place. Angle measures to the nearest whole degree. I'm going to hit the pause button. I want you to do that on your own. It should take you about 4 to 5 minutes, and then restart. All right, students, let's see how well you did on your own. You should have noticed you have a right triangle here, so right triangles are pretty much everything. And if you have 2 sides and you need a 3rd side, tag. So we can come here and we're going to do 5. Have 2 sides, need a 3rd side, we're going to tag here. So we have ourselves 5 squared plus 12 squared equals, we'll call that there, x squared, 25. I'm going fast because you should already have the math here. Hopefully you're not copying my math, you just did this yourself, and we found that all our sides here was a 13 and a 13. And of course, if this is 5, this is 5. We're going to come over here, and we're going to get 5 squared plus 6 squared. Let's call this y. Okay, so that's going to be square root of 61 equals y squared, and square root both sides. And we got 7.8 over here. Now we have all our segment lengths. You're like, how do we find angles? Well, this is where you do inverse SOHCAHTOA, inverse SOHCAHTOA. So I'm going to go for my theta right here, and I'm going to label. Now you might have done mine differently. As long as you get the same answer, we're fine. I'm going to use inverse tan. opposite, which is 5, over adjacent, which is 12, gives us theta. And we're going to round to the nearest whole degree, so we got 23 degrees here, which makes this 23 degrees. We got ourselves a right angle here. Take it away from 180, 67. 67. Now be very careful. Students like to think that the pink is 67. It is not. You have to do this again because that's a completely distinct triangle. So we're going to go for that theta right there. So my opposite is going to be 6. My adjacent is 5. Inverse tan again. And I'm getting 50 degrees. Makes that 50, right angle, 40 degrees, 40 degrees. Once again, all your right triangle stuff is coming back to say hello. Students, please take time to go back and review what was the basic content of each page. Recap that verbally, and that will help you solidify your understanding of the material.